Hello and welcome to part 2 of lesson number 5 in Unit 2A in our grade 10 academic math class. This is solving right angle triangles. I'm not going to spend any time recapping. If you need a recap, go watch the first part of this video. We're just going to keep moving and solve a second triangle so we don't waste any more time because I'm chatty and I know sometimes people want to get through these things. So let's just get right to it. Here we are given another triangle. So we have triangle GHI where angle H is 90 degrees. Side HI is 9.2 centimeters and side GI is 11.3. You might want to pause here, copy this out, and then we can start to work on putting the information in and then working through it. So hit pause here, copy this down, these sort of bare bones, and then come on back when you're done and we'll keep rocking. All right, let's keep rocking. So we've got our 90 degree. Again, that's already in there. I put that in when I drew it, so there is the 90 degree. Side HI, or side little g, is going to be 9.2 centimeters. And side GI, which is also side little h, is 11.9. Sorry, 11.9. I think it was 11.3. Yep, 11.3. All right, so let's pop those values on the table as well. H is going to be equal to 90 degrees. Side little h was 11.3 centimeters. And side little g is 9.2 centimeters. All right, so our strategy last time of just finding that third angle won't work this time. We only have one angle, so we're going to have to find an angle. But in the spirit of kind of flexing all of the muscles, let's go and get side little I first this time. Again, there's no right way to do this, but if we go get little I first, we'll get a chance to use the Pythagorean Theorem. So let's start with that. Number 1, find little I. And we're going to do that by doing the Pythagorean Theorem. So using the appropriate letters, we know that the hypotenuse squared, in this question is h squared, is equal to I squared plus g squared, I think. There we go. That's using this one here is the hypotenuse and the other two are just the other legs of the triangle. So now let's start substituting in values that we know. This is 11.3 and it's going to be squared. We know little I, or rather we don't know little I yet. And we know that little g is equal to 9 point something, 9.2 squared. So let's start to isolate little I. I'm going to transpose 9.2 squared, which is a number. I don't need to know what it is just yet. I'm going to subtract 9.2 squared from both sides. So that's going to give me 11.3 squared minus 9.2 squared is equal to I squared. Now I'm going to do that all in one step. I'm just going to use my calculator. I'm going to lean on it. So 11.3 squared minus 9.2 squared is equal to 43.05. And remember, that's our I squared. How do we get to the actual I value? We take the square root of that bad boy. So there we go. We're going to take the square root, 43.05, and that equals 6.56. So let's call that 6.6 centimeters will be equal to little I. Let's get that in the table. 6.6 centimeters. All right, there we go. So first part down, 2 angles to go. If you recall, the way that we find an angle is to essentially, I think a lot of times in that particular lesson and its homework, we were given the angle that we were going to be finding first. In this case, it can be G or I. It doesn't really matter. And I'm going to pick I just because it's closer to the bottom. No other reason. So there's I. We're going to use that as our reference angle. So from here then, our hypotenuse conveniently is labeled H. Our opposite inconveniently is labeled little I. And 9.2 is the adjacent. And I have no feelings about that. All right, so here we have it. We have both the, I'm just changing up my colors here. What sides do we have? Again, I'm going to steer clear of using little I because I just found it. And if I made a mistake in there, that would kind of suck. So I'm just not going to bother with that one. I'm going to use the two that I was given in the question. That's adjacent, hypotenuse. Which trig ratio uses adjacent and hypotenuse? Hopefully you know that's going to be cosine. So we're going to go find angle I. That's number 2. Find I, or find angle I guess. Find angle I. All right, so we're going to take the cosine of angle I will be equal to, and it was the adjacent 9.2 over the hypotenuse, which is 11.3. How do we get to angle I? Well, we take the inverse cos, which is shift cosine of 9.2 divided by 11.3. We're going to pop that in the old calculator, and let's see what we get. So there we go. Shift cos gives us our cos -1. Open a bracket. 9.2 divided by 11.3, close the bracket, equals, and that gives me 35.4. Now it's 4.9, which sucks because it's kind of right in the middle, but if we're going to follow the rules, it should be 35.4, which will be 35 only. So 35 degrees, let's put that in the table. Angle I, 35 degrees. Now again, at this point here, if we wanted the easiest path, we could just go forward and do the sum of interior angles again, and I don't see any reason to take the hard way. So let's do that. Number 3, find angle G. Find angle G. Delightful. So we know that angle G will be equal to 180 degrees minus the two angles that we already have, which is a 90 and a 35. So when we do that math, angle G then should be equal to, let's see, what's that, 55 degrees, give or take. That should be approximate. Actually, I've probably missed a lot of approximates along the way. Yep, I sure did. We'll just pop those in retroactively. So that should be 55 degrees right here for angle G. Before we move on, let's do our quick dummy check here just to make sure. We did get all three pieces of information, but let's see if they make sense. So what is our largest angle? 90 degrees. Does it correspond to our largest side? It does, 11.3. Smallest angle? 35. Smallest side across from it? Yes, it is, 6.6. So our dummy check checks out. We have every reason to think that we did a good job with this question. And who knows, maybe we did. Moving on to a final example here. This is what they would call a double right angle triangle question. So they want us to find side EF to the nearest tenth of a meter. So let's highlight EF here first. There's EF. Now, the thing about a question like this is we are not going to be given enough information to get this in one step, typically. I wouldn't say never, but it's not common. What we need to do is actually imagine a way that we could get enough information, because if we look at this, let's just look at triangle. I'm going to change up my, highlighter here. So if I look at triangle EFG, what you'll notice is that you have two angles. You've got the 90 and you've got the 35, but we don't have any side lengths. Side lengths are crucial for us to be able to figure stuff out about triangles, even more so than angles. So if we don't have any side lengths, we're in trouble. However, if we look at triangle EDG, which is, I'm looking for a color, that's this one over here, what you'll notice is that while we are given two angles, we are also given a side, and that helps us. So is there any way that we can figure something out with triangle EDG that will then become helpful if we were looking at triangle EGF? And the answer is yes. They have this beautiful shared side running right down the middle. This side EG is common to both triangles. It's the hypotenuse of the blue triangle, and it is one of the non-hypotenuse sides of the triangle that I've sort of done like a purple there. So what we need to do is we need to find side EG using triangle EDG, and then once we have that side length, we can use it in triangle EFG to figure out the piece that we're after. Hopefully that makes sense. Let's start in with a little bit of going to get side EG. So we're going to do number one. We're going to find EG. And we're going to do that by getting a reference angle. So let's grab a color here. Let's call our reference angle here 43 degrees because that's the one that was given to us. So from 43 degrees, the side that we know for sure is the opposite. That's right across from it. And the side that we want is the hypotenuse. I'm going to write that inside this triangle because it's going to have a different value in the triangle beside it. So we have the opposite. We want the hypotenuse. Which trig ratio uses opposite and hypotenuse? The answer is sine. So we are going to do the sine of our reference angle, which was 43 degrees. It's going to be equal to the opposite side, 150.5 I think it was, yep, over the hypotenuse, which we don't know. So that's our EG. From here, we set up to cross multiply. Let's get that happening. So we have now EG times sine 43 degrees is equal to 150.5. How do we get to EG all by itself? We divide both sides by sine of 43 degrees. And there we go. We've got side EG is equal to, let's put that through the calculator. So we have 150.5 divided by the sine of 43, and that's going to equal 220.67. So let's just call that 220.7. 220.7, I think it was centimeters possibly. Oh, meters. There we go. So we now have a value, side EG. We can use that as we move forward into finding side EF. So let's jump back into this triangle, because now what we have here is we know that this is 220 point, what did I say it was? 220.7. So now we have 220.7 here. Let's create a second reference angle. And by a second reference angle, I mean a reference angle that exists in this second triangle here of 35 degrees. So what side do we want? The side that we want is actually our hypotenuse. That's our side EF. What side do we have? The side we have is our adjacent side. So what trig ratio uses both adjacent and hypotenuse? If you said cosine, you would be correct. So let's go find side EF. Number 2, find EF. So we're going to set that up. The cosine from our reference angle was 30-something, 35. Cosine of 35 degrees equals the adjacent side, which is 220.7, over the hypotenuse, which we don't know. It's EF. Set cosine of 35 degrees over 1. Now we cross multiply. Let's get that happening. We got EF times the cosine of 35 degrees is equal to 220.7. How do we get EF alone? Well, we divide both sides by cos of 35 degrees. And let's get a little look at what that looks like. So EF equals then approximately, so we have 220.7 divided by the cosine of 35 degrees, and that's going to equal 269.4. So 269.4 meters. And that is our final answer. Not a word problem, so we can just sort of leave it as it is. Hopefully this lesson was helpful to you, sort of a putting it all together kind of lesson. I think this might actually be the last lesson in this unit. It is, which is great. So from here we're going to be moving on to onto an assessment. So obviously some homework first, but then an assessment, and then after that we're going to move into the second half of this unit, which is when we start to get away from right angle triangles. So good luck with the homework. Any problems, reach out via email. You can reach out in the classroom. You can reach out when you're physically in the classroom, or you can reach out by sort of videoing into the classroom. Whatever works best for you, we'll get your questions answered. Good luck with the homework, and good luck with the assessment too.